All right, in this lesson, we're going to be talking about graphing linear inequalities. Now, what is an inequality? We've talked about equations where there's equal signs here, where x is equal to 4 or y is equal to -3, whatever the answer might be. But sometimes there's inequalities. We actually use them in real life when you have a maximum or a minimum, meaning it doesn't have to be an exact number, it just has to either be a number greater or a number less than a given value, okay? So linear inequalities use greater than signs, less than signs, greater than or equal signs, or less than equal signs to show that there's many solutions to the word problem. So it asks you to look at the interval summary table. Again, this is right off the internet, not something that I made up myself. Take a look at this, and basically this is what it looks like in the inequality. You graph it on a number line. This is what it means in words. And then this is the interval notation where you would have to write your answer. Keep in mind that number lines have to go from the most negative numbers up to 0 and then all the way to positive numbers. So in the left direction, that's negative infinity, meaning it goes on forever and ever in the left direction. And in the right direction, this is positive infinity, means it's going to go on and on and on to higher and higher numbers. All right, notice that brackets indicate that these points are included in the solution. So if it has a little equal sign here, then that means you use these brackets. It's kind of hard to see here, but we'll make it darker, okay? If it has an equal sign, this is brackets as well. So it's all the solutions that are less than this, including this number, or greater than this, or including this number. Parentheses means it's not including the number, okay? Or if you end up using infinity or negative infinity, you always have a parentheses with that because it's impossible to include all possible numbers in the universe that goes negative or that goes positive. All of these lessons are based on Blitzer's Introductory into Intermediate Algebra for college students. So you're going to need to know whether to use brackets, parentheses, and so forth. So again, in real life, what is this used in real life, this inequality thing? Basically, inequalities in real life are used all the time. So for example, you have a credit limit. If you get a credit card and it says that you can spend up to $3,000, you don't have to spend $3,000. You can spend $419 if you want to, or $212 or whatever. So it's a maximum amount, but it can be any number up to that amount and including that amount. So that would have a bracket because it's including the 3,000. Speed limits, well, we don't really listen to those too much in Texas, but generally a speed limit means that you can go any number below that. Well, you couldn't really go like 15 miles an hour on the freeway when it's a 65-mile zone, but basically there's kind of a range, and so you're not supposed to go above that, or they can give you a ticket because they consider it dangerous for you and other drivers. Drinking age, you have to be at least 21. You don't have to be exactly 21. You can be 21 or older to drink legally in the United States. Well, in most cities. Fuel mileage, okay, there's only a certain amount of maximum miles that you're going to get out of your fuel tank, or under. Like, you don't have to go out every time you leave and drive until your fuel tank is empty. You can drive up to that many miles before refilling. There's a maximum and a minimum age for enlisting in the military. So you have to be a minimum of 18, but you can't be over, I think it's like 40 something. I don't actually remember the number. Maybe it's 38. Also, there's a minimum daily caloric intake that you should have for your body on average to survive, and a maximum also. Both of those could cause death if you had too much or too little on a consistent basis. So we use maximum and minimums all the time. All right, so here we want to graph the inequality on the number line. These number lines have no numbers on them, so you get to choose. So if I want this to be 0 and 1 and 2 and 3, I can make it whatever I want to. This is basically saying all the numbers less than 3. If you want to think of the less than as like a little Pac-Man, the Pac-Man's always going to go to the bigger side, okay, the most, okay. So 3 is the bigger side. So this X represents all the numbers that are not as much as 3, less than 3. So this little shading here indicates that 2 is correct. 2 is less than 3. 0 is less than 3. -1 is less than 3. All these answers are solutions to this problem. So that's what graphing is. You graph it on a number line. If it wants you to write it in interval notation, then you're going to use those parentheses that we were talking about earlier, the brackets or whatever. You always write interval notation from lowest first, then highest, and then you either use brackets or parentheses depending on what's appropriate. You wouldn't use both. I'm just showing you that. So the lowest that this can be goes on into negative infinity. The highest it can be is 3. It can't include negative infinity, and it doesn't include 3, so you have to use parentheses. Remember, parentheses are always used in infinity or negative infinity, and parentheses are used when it's not included. There's no equals part here. It has to be less than 3. So it can't be equal to 3, just less than 3. All right, here we have a greater than or equal. This tells me that I'm going to have a bracket, okay? So I have -1 or -2, -1, 0, 1. You don't actually have to put all the numbers in here. I'm just putting more than necessary. So it's all the numbers, and the Pac-Man is open to this side. His little mouth is open to this side. So these are bigger. There's more of them. So these are all the numbers that are bigger than -1, okay? So they're all the numbers that are bigger than -1. Does it include -1? Yes. The or equals to means greater than or equal to -1. So when I write this, my lowest is -1. My highest is infinity, lowest to highest. Lowest is -1, and all the numbers are higher. You can never include infinity. In this case, you do include the -1 because there's an equal sign. What about this one? Well, this one's kind of weird because it's all the numbers more than -1. Okay, so it's all these numbers more than -1, but it's also limited by all the numbers less than or equal to 3. So we've got a 3 and we've got a -1. So the window is between -1 and 3. So it's more than -1, but less than 3. It's kind of like the speed limit. You have to go more than 40 miles an hour, but less than 60. So you got to go between those two values. All right, so this has no equal sign, so this is a parentheses, excuse me. And this does have an equal sign, so this is a bracket because it includes this. So when you write this, lowest number is -1 on a number line. The highest number is 3. -1 is not included. 3 is included. Okay, you practice the bottom. Give yourself a pat on the back. If you didn't do well, just go back and review it. Okay, so we're also talking about how to solve linear inequalities. What happens if the x is not already isolated like we had, or the y, or whatever? So there's certain properties of inequalities. If you want to add something to both sides in order to isolate the x, you can. If you want to subtract something from both sides, just like you would an equal sign, you can do that too. If you want to multiply both sides by a positive number, like you want to multiply the left by 2 and the right by 2, you can do that. If you want to divide both sides by a positive number, divide it by 3, you can do that too. There's a special rule that says, however, if you multiply by a negative number, or multiply both sides by a -2 or a -6 or whatever, or if you divide by a negative number, if you multiply or divide by a negative number, you have to turn your inequality sign around. What started as a negative, or excuse me, a less than, you would change it to a greater than. If it started as a greater than and you multiplied by negatives, you would change it to a less than. So you would have to switch the inequality sign. Again, if you start with a less than and you divide by negatives, you have to switch it to a greater than. If you started with a greater than over here and you multiplied it by or divided by negatives, it would become a less than. So what do you notice about the inequality sign? If you multiply or divide by a negative, the inequality sign switches directions. So it used to be a greater, now it's less. Used to be a less, now it's greater. You have to switch it. Just the inequality signs. You still follow all of the mathematical rules for multiplying a negative times a negative, or dividing a negative by a negative, or dividing a positive by a negative, or so forth. You still follow all those. Those don't change. What does is different about this is that you have to change the inequality. Let's look. All right. I want x alone. I can't graph this when there's all this stuff next to x. I have to have x alone and then everything else on the right hand side. So if if this were a 1/3 x is equal to 5, we would multiply this side by 3 and multiply this side times 3. These two would become 1, so you get x is equal to 15. That's how you would do if it were an equality. But we don't have equality. You have an inequality. So that means that you have to use your greater than, less than signs. Well, this was less. We multiplied by a positive number, so nothing changed as far as my sign. So this tells me all the numbers that are less than 15, because 15 is bigger. So here's 15. All the numbers that are less than 15 is out here. Since there's no equal, this is a parentheses. So it's negative infinity is the lowest. 15 is the highest. They both have parentheses. Notice that this problem has 3 parts. It tells you to solve it, tells you to graph it, and it tells you to write your solution set in interval notation. 3 parts: solving, graphing, interval notation. Here we go. We're going to divide this side by -3 to isolate x. And whenever you divide or multiply by a -3, what did we just learn? We just learned that when you multiply or divide by a negative number, this sign switches. This becomes -3 divided by -3 is still 1. But instead of less than, I have greater than. 21 divided by -3 is -7. This math doesn't change. It's just the inequality that changes. So I have like -8, -7, -6, or whatever. It's all the numbers more than -7. And there's a parentheses because it doesn't include the -7 or the infinity. All right, we're almost done here. So we're going to isolate our y. Treat it just like an equality unless you're multiplying or dividing by a negative number. This is dividing by a positive, so the inequality part doesn't change. So it's all the numbers that are more or equal to 3. 3 is my lowest, infinity is my highest. I use a bracket here and a parentheses there. You try to do the ones on the right. Let's do the great reveal, if we can. And here we go. Check to see how you did. All right, see you next time.